Okay, geometry, this is the second day of chapter 10, section 1, where we're developing formulas. And today we were going to talk about the rhombus and the kite, right? Okay, so here we have a little reminder that the diagonals of a rhombus or the diagonals of a kite are both perpendicular. And in the case of a rhombus, the diagonals bisect each other. So I'm going to try to draw that here, and these are not in your notes, so why don't you go ahead and draw a rhombus and show that the diagonals are both perpendicular, and look at, they bisect, two equal halves. Notice in the case of the kite, we have the perpendicular diagonals, and this is actually a real kite. I thought you'd enjoy that. But notice, of course, that particularly this longer diagonal is not bisected. So with a kite, you don't have a bisected longer diagonal, do you? So the area of a rhombus or kite takes into account their diagonals, which is really kind of cool. This is something new. The area equals 1/2 of the product of the diagonals. Okay, so think about if I took this diagonal and multiplied by this diagonal. Imagine I would create double the size of this kite, right? I could fill all these areas out here and have a twice as large an area, so I need to take half of this, right? Same is true with this. If I multiply diagonal 1 all the way across times diagonal 2, I'm going to have twice as large a rhombus, so I need to take half. Reminds me of our triangle formula. So let's find a missing diagonal of a kite where we're given the diagonal 1 is 14 inches and the total area is 238. Go ahead and pause and come back and check your answer. Okay, this is one of the simpler ones where we're given actual values, so we simply start with the formula for the area, the kite, and we substitute known values. And we can take half of 14 as 7 and divide both sides by that. So you should have 34. Very good. So let's try it with a rhombus. Find the area of a rhombus, and now we have more interesting expressions for the diagonals. Well, go ahead and pause, come back. Of course, we're going to start with the formula for the area of a rhombus, same formula, and substitute the known values, which are binomials, right? So we're going to have to use our multiplication, right? And we're going to have an expression involving x in our answer. And there you go. Now, if we had some value for the area, we might be able to find x, right? Very good. So here's a fun problem where you're asked to find the area of a kite and you're given some interesting information. And so the first thing we want to do is find the lengths of the diagonals. If we have those, we can find the area of this kite, right? So we're missing x and y. And remember, though, that while it might not look exactly perpendicular, we know that these diagonals are forming perpendicular angles, 90-degree angles. So we have a bunch of right triangles. So which of the variables can we find first? And if you're saying y, very good, because we know that it is one of the legs of this right triangle where we know the other leg is 28 and the hypotenuse is 35. So pause, find y, and come back. And just plugging that in, we should have a y value of 21. Whoops. Now when we have y, simply use your Pythagorean theorem to find x, which is 20. Okay, so if x is 20, what is this diagonal here? Very good, 48. And if y is 21, we know that this is, second diagonal is 42. So with a diagonal of 42 and 48, we can find the area, right? So that's what we're doing in the next slide. And so go ahead, pause, come back and check your answer. And you should have 1,008 inches squared. Okay, in this application we have a tile design. And it is a rectangle with a base of 4 inches and a height of 2 inches. So we're asked to use this grid to find the perimeter and area of the leftmost shaded parallelogram. the leftmost shaded parallelogram would be, excuse me, this piece here. Straight down, we go up, down, and across. Okay, we're asked to find the perimeter. Okay, so that's probably the trickier question. So the perimeter would be, just to walk around, right? If this base is 4, then 1 unit here is equal to 1, right? And if the height was 2, then this unit is equal to 1 as well. So it looks like we have a unit 1 here and a unit 1 here. And what would the value of this be, this diagonal? Well, this diagonal is the same, right? And this, they are diagonals, the hypotenuse of a right triangle, right? So knowing that this right triangle has 2 legs of 1, we would use our Pythagorean theorem. So 1 squared plus 1 squared is 2 equals c squared. So the diagonal is, that's right, the square root of 2. So we would have square root of 2 plus 1, square root of 2 plus 1. And so we talked about finding perimeter yesterday. You can find 2 times the square root of 2 plus 2 times 1, or you could do square root of 2 plus 1, that whole quantity, times 2. Either way, we get 2 plus 2 times the square root of 2. Okay. Now we're asked to find the area of the leftmost. Were we asked to find the area? I guess we're doing the area at this point, right? So if we're going to find the area of this, we are looking for the base and height of this shaded parallelogram. This is pretty easy because imagine we could take this lower piece of the parallelogram and place it up in this unshaded region, this tan region, and we would have basically a rectangle that is what dimensions here, base and height. We have a base of 1 and a height of 1, so our area is simply 1 inch squared. Very good. Okay, try this and see what you can come up with. You're asked to find the perimeter and area of the large green triangle. Each grid square has a side of 1 centimeter, so pause and come back and check your work. Okay, perimeter again is kind of the trickier of the 2 questions. If this is a 1 by 1, if each of these are 1 by 1 squares, then we have 1 by 1, and what would that hypotenuse length be? Once again, good, the square root of 2. So we have square root of 2 happening 1, 2, 3, 4 times, right? And then we have this base, which is simply 4 units. So the perimeter is 4 plus 4 times the square root of 2. Now our area is, can you jot down the formula for the area of a triangle? Good, BH over 2. So 4 times 2 is 8 divided by 2 is 4 centimeters. Good job. Can you find the area of this rhombus? Pause the video and come back. Okay, remember it's a rhombus, so if we were to go ahead and place the second diagonal into the figure, we know that these diagonals are perpendicular and, good, they bisect. So we have 72 was this long length. When we bisect that, we end up with 36, right? So we have 36 here, and we know this side is 39. So we can use that information to find the unknown leg. And so go ahead and find it. Okay, using your Pythagorean, hopefully you found that this half of the second diagonal is 15, right? Good. So once we have that, we now can determine the entire length of this diagonal, which is, good, 30. So recall the area of a rhombus is half of d1 times d2. This is multiplication here. So d1 times d2 over 2. And so your answer, so A should equal 1,080 meters squared. And I've lost my squaring feature, so make sure you square these meters here. So I can grab a pen and square it this way. Very good. And the last question is here. pause, come back and check your work, and hopefully you have the answer 3 inches squared. Good. There's your work. Have a good day.